This is mathheals.com, where you can find more links to math and computer science YouTube videos. And let's take a look at rationalizing radical expressions. Now this is based upon something we've already discussed. Remember when we talked about fractions and radicals? Basically had two rules. Excuse me. No fractions inside of a radical. Still not over my cold I had. And the second rule was no radicals in the denominator. Well, this section goes over techniques to get rid of these. Now, we've seen some other techniques to simplify them to get rid of them, but those don't work all the time. So let's look at our first one here. We got 3 over the square root of 5. It says rationalize each denominator. That means just get rid of those two conditions that we talked about. Assume all variables are positive. Well, this is the idea of this is based upon what we saw in the previous lesson. If your square roots are the same, like I got square root of 7 times square root of 7, if we're talking about square roots, they basically cancel each other out, so you just be left with 7. Now the problem here is we can't have radical in denominator. So what we're going to do is we'll multiply the bottom part by square root of 5, and we'll multiply the top part by square root of 5. And we'll see why in a second. 3 times square root of 5 is 3 square root of 5. And down below, when you got a square root of 5 times square root of 5, that just gives you 5. And notice we no longer have a radical in denominator, do we? So that's our answer. Now we'll have to handle a little bit differently when we don't have a square root down there, where we have a cube root or fourth root or something. Let's take a look at our second example. 7 over the square root of 28. Now remember earlier lesson I said you should simplify a radical before you do anything. So that's what we want to do. Square root of 28. 28 is 2 times 2 times 7. So excuse me. We're looking for a pair of something since we got a square root. Here's a pair of 2's, so those pair of 2's are going to come out in front. So I'll have 7 over 2 square root of 7. Now again, the main problem here is that we got a square root down in the denominator. Now the 2 doesn't cause us a problem, just the square root. So we want to multiply the top and bottom by the square root of 7. 7 times square root of 7 gives us 7 square root of 7. And here we have the 2 carries down, and square root of 7 times square root of 7 gives us 7. Now these 7's would cancel here, and we'll have square root of 7 over 2 as our answer. And again, we got rid of the radical down in the denominator. Let's take a look at this one. Well, the main problem here is we have a fraction inside of a radical, and we said earlier, if you have a fraction inside of a radical, you can split it up, put a radical around the top and a radical around the bottom. That was in the previous lesson. So we don't want to have a fraction inside of a radical, but we have a radical in the denominator. Well, since this is a square root, we can multiply the top and bottom by the square root of x. Square root of 7 times square root of x gives us square root of 7x. Remember, when you're multiplying radicals together, you just multiply what's underneath them and put it under a single square root. Now, let me go ahead and show that step here. This would be x times x. Square root, we're looking for a pair of somethings. So here's a pair of x's, so they're going to come out as a single x. So we've got square root of 7x over x. And that's our answer. Now I showed the step on this particular problem, but remember the square root of x times square root of x would just give you x. But the reason why it gives you that is this step right here, which is going to become important in the coming examples. Let's take a look at this one. We got the cube root of negative 9 over x. Well, first off, remember we said that if you have a index that's odd and you have a negative number inside your radical, you take that negative and put it on the outside, so we don't have to worry about it. Okay, well the main thing that's wrong here is we got a fraction inside of a radical. So I'm going to split it up, put a radical around the top, and I'll put a radical around the bottom. So we got the cube root of 9 over the cube root of x with a negative. Well, we got rid of the fraction inside the radical, but we still have a radical in the denominator. Now try to figure out what to multiply this by. Notice our index is 3, which means we need 3 of something, whatever it might be. Here we have 1x, so I need 2 more x's. Because if I have 2 more x's, I'll have 3 x's total. Again, it has to match whatever your index is. And whatever we multiply by the bottom, we have to multiply by the top. So I got negative and cube root. 9 and x times x is x squared, so we got 9x squared. And down below, our index is 3. We got 3 x's, so that gives us a single x. And that's our answer. Let me start a new page. Okay, so we got 4 over the 5th root of 64 x to the 3rd. Now, to begin with, you want to simplify these as much as you can. 64, that's 6 2's, I think. 2, 4, 8, 16, 32, 64, yeah. And x to the 3rd is 3 x's. Well, our index is 5, so we're looking for 5 of something. Here's 3, 4, 5 2's. Those 5 2's going to come out in front as a single 2. And we're left with 1, 2, and 3 x's. Well, to begin with, as 4 and 2 will simplify these numbers. So I got 2 over 5th root of 2 and then 3 x's. Okay. Now the main problem here is, again, we have the radical down in the denominator. We can't have that. So try to figure out what to multiply it by. Our index is 5, which means we need 5 of whatever. We have 1, 2. That means we need 4 more 2's. We have 3 x's. That means we need 2 more x's. Because you need 5 of everything to get rid of the radical downstairs in this problem. Whatever you multiply by the bottom, you have to multiply by the top. Okay, so up on top, we got 2, and then the 5th root. 2, 4, 8, 16. X times x is x squared. Over, our index is 5. We got 5 2's now, so that gives us a single 2. Our index is 5. We got 5 x's, so that gives us a single x. And our radical's gone. 2's would cancel, and we have the 5th root of 16x squared over x. And that's our answer. Now notice it still says assume all variables are positive. Otherwise, we might have to worry about putting absolute value bars around some of the variables when we bring them out. Not all of them, but some of them you would. Let's look at this next one. We got 4, and then the 7th root of a squared b to the 4th. Well, there's no simplifying due to up front up here, so let's just see what we have. We got index is 7. Means we need 7 of whatever. We got 2 a's. Well, we need 7 A's, so if I got 2 A's, I need 5 more. We got 4 B's. I need 7 B's, so I need 3 more. And whatever you multiply by the bottom, you have to multiply by the top. So we have 5 A's up there, and we got 3 B's. So that gives us 4 7th root of A to the 5th, B to the 3rd, over, where our index is 7, we got 7 A's, so we bring out a single A. Our index is 7, we got 7 B's, so we bring out a single B. And that's our answer. I think these are kind of fun myself, because you just look at your index, that tells you how many you need of whatever. You just have to make sure you simplify first. Like on problem number 5 here, my index is 5, I might think I need 5 64s, and then it becomes really huge numbers. But if I do the prime factorization and bring out that out first, makes it a lot easier. Okay, let's look at this next one. This one's a little bit different. Has a different technique for getting rid of the radical downstairs. We got 8 over the square root of 5 minus 1. Now all these previous problems just had a single square root down your denominator. This one's different. We have a square root and a number. To get rid of the radical on these, the square root specifically, I don't think I've ever seen a cube root or fourth root down here. I'm not even sure how you get rid of it, to be honest. To get rid of it, you multiply top and bottom by the conjugate of the bottom. Now if you remember conjugate from the previous lesson, conjugate means the first and the last are the same. So this will be the square root of 5, and this will be 1. First is the same, last is the same. But the sign in the middle is different. See how this is a minus? This will be a plus. And whatever you multiply by the bottom, you have to multiply by the top. So up on top, we got 8 times square root of 5 plus 1. And down below, since they're conjugates, all you have to do is multiply your first parts together and your last parts. Square root of 5 times square root of 5. Negative 1 times a positive 1. Now up on top, 8 times square root of 5 is 8 square root of 5. 8 times 1 is 8. Down below, square root of 5 times square root of 5 is 5 minus 1 times 1 is 1. So we got 8 square root of 5 plus 8 over 4. Now notice that on top they have a GCF. I could factor an 8 out, but even less than that, I could factor a 4 out. And that would give us 4 times 2 square root of 5 plus 2 over 4. Now why did I choose 4 instead of 8 to factor it out? Well, I noticed there's a 4 down in the denominator. And if I factor out a 4, these would cancel. So that gives us 2 square root of 5 plus 2. And that's our answer. Let me start a new page. And let's take a look at this next one. Two square root of x over square root of x minus square root of y. Again, the problem here is we got square roots, we got radicals in the denominator. They don't have to be square roots, you just got radicals in the denominator. Well, again, we have 2 of them here. You got a minus between them. That means we need to multiply top and bottom by the conjugate of the bottom. Conjugate is the first is the same and the last is the same. So both of these are square root of x, and both have a square root of y as the last. But the sign in the middle is different. This is a minus, so this has to be a plus. And whatever you multiply by the bottom, you have to multiply by the top. So we're going to have 2 square root of x times square root of x plus square root of y. And down below, since these are conjugates, we just have to multiply our first parts together. Square root of x times square root of x minus, and multiply our last parts. Square root of y times square root of y. Well, up on top, I'm going to take this 2 square root of x times square root of x and times square root of y. So I got 2 square root of x times square root of x plus 2 square root of x times square root of y. And down below, square root of x times square root of x is x minus square root of y times square root of y is y. Remember with square roots, if they're the same, they cancel away. So up on top here, this will also become x. So this is 2x plus 2 square root of xy over x minus y. And that's our answer. Again, notice we don't have a radical in denominator. That's the main problem. Let me start a new page. And let's take a look at this last one. Again, the main problem is we have a radical in denominator. And even more than that, we have something besides this, a single radical. And that's where you have to multiply with a conjugate. Conjugate, the first part is the same, last part is the same. So this is square root of x, this is square root of x. This is 2, and this is 2. But the sign in the middle is different. Since this is a minus, this will be a plus. And whatever you multiply by the bottom, you have to multiply by the top. So up on top, we got square root of x plus 2 times square root of x plus 2. And down below, since these are conjugates, all you have to do is multiply your first parts together, square root of x times square root of x, and your last parts, negative 2 times 2. Now up on top, square root of x times square root of x, multiply those. Square root of x times 2. 2 times square root of x, I'm just foiling, if you're used to that technique. And 2 times 2. There. Down below, square root of x times square root of x is x, minus 2 times 2 is 4. Up on top, square root of x times square root of x is x, plus. Now this is 2 square root of x, this is 2 square root of x. Since the radicals are the same, we can add numbers in front of them. So this becomes 4 square root of x. And 2 times 2 gives us 4, all over x minus 4. May look more complex, but we got rid of the radical down in the denominator, which is our main issue. That's the end of that video. So I'm going to go ahead and save it.